And again, that's dropped. You come over here, the high end, it's when you get to about 100,000 cells per liter or higher, that's when you actually see visually, you can see the discoloration in the water. Now you've got enough toxin there that you start getting fish kills. And we could also detect it by satellite and so on. Okay, so that's when we become aware of it. Okay, and this is what everyone focuses on, right? That's when you start seeing dead fish. And sure enough, in all these high concentration categories, you see a dramatic increase from 50 years ago. But what about this in here? All these categories have also increased, and these are what we call sublethal concentrations. First of all, you can't see it. I mean, you can count if you look at it under a microscope, but you can't see it visually in the water. And it's not enough to kill the fish. So the average observer would not be aware there's any red tide. It's not enough to kill things. Okay? But there has been a dramatic increase in these sublethal concentrations. So what's happening is that toxin does get into the fish. It's just not enough to kill them. Now, I know you can't see the numbers in it, but a colleague of mine looked at like 30 different species of fish, and this is during a time when there was no red tide or anything, and yet you see the brevetoxin in their tissues. Okay? And that probably explains why what we're seeing now are dolphins out in the Gulf dying. There's no red tide around. Okay? Yeah, when you do the autopsy, they're packed full of brevetoxin. They got a lethal dose of brevetoxin. Okay, what's happening? They're eating these live fish. It doesn't kill them initially, but over time you build it up. It's just like methyl mercury. Okay, it's a lipid-soluble compound. Your body can't get rid of the toxin. It can't excrete it, so it just slowly builds up. So yeah, I mean, it's okay if you eat, a swordfish meal once a month, something like that, maybe. But you start eating it every day, you're going to come down with mercury poisoning. It's the same thing. I mean, that's what dolphins eat. They eat fish. Okay, they eat it every day. And so I think what's going on is they're slowly building up, because they only eat the live fish, but they're slowly, these low concentrations just slowly build up in their bodies until they end up with the lethal dose. And I suspect that might be why we see people, I think what happens is, and the general guideline, I think, is during red tide, if you see dead fish, you know not to eat it. But if you catch a live fish, people, I think, assume it must be okay. Well, they didn't get a lethal dose of brevetoxin, but there's some brevetoxin in there. Okay. Just not lethal enough, but it can still have an effect on you. Okay, now, that was the brevetoxin. Now I want to go back to blue-green algae. Look at the health effects of the blue-green algae. Okay, remember that bloom in Florida Bay? That was blue-green algae. Okay, Lake Okeechobee, you can see Lake Okeechobee is like 800 square miles or so, and you can see huge blooms of blue-green algae in there. Last summer was like covered 90% of the lake. Sort of this view. I already showed you Caloosahatchee River. That's the famous guacamole bloom over in St. Lucie, estuary on the east coast. Happened 3 years ago. Okay, a close-up of it. Okay, well, these blue-green algae are known to produce a lot of different types of toxins. I won't go into all the different types. I'm going to focus on, one particular one. This is the best known toxin called microcystin, a very large complex molecule. Okay, it's well known to cause a lot of animal deaths, human deaths, can lead to gastrointestinal disorders and so on. This was actually discovered like 100 years ago in Australia. A bunch of sheep died. So what happened? So you investigate, well, they all drank from this pond over here, and that pond had a bloom of blue-green algae. So scientists get samples of those blue-green algae, analyze their chemistry, and that's how microcystin was discovered. And that's how virtually all the algal toxins have been discovered that we know about. Okay, in other words, a bunch of people get sick. Well, what do they all have in common? Well, they all ate at this restaurant last night, and they all ate the clams. When you work back, well, those clams are harvested from this estuary over here, and you go look, and there's a bloom of certain species of algae. You study the chemistry, and you discover the toxin that got all those people sick. Okay, so that's how virtually all these toxins get discovered. But once you start studying the biochemistry, exactly the mechanism by which microdystrophin causes these deaths and so on. You discover it can also lead to long-term liver damage. Its tumor promoter can lead to like liver cancer. Now, just assume for a second that you have a toxin that does not cause any of these short-term effects and can only lead to, say, liver cancer. Well, liver cancer occurs 10 or 20 years later. Well, now people are dying at different locations, different times. How are you ever going to track it back to a meal they had 10, 20 years earlier? You're never going to be able to figure that out. Okay, so that's my concern. Toxins that have no short-term effect only have long-term effects. It sounds kind of odd, but I think I'm my next slide. Yeah, there's just consider different types of compounds, nasty compounds produced by algae. Some of them just smell bad. Okay, if it's drinking water, it makes the water taste bad. Some of them can intensely irritate your skin if you go swimming in the water. Cause gastrointestinal disorders, various neurological disorders. Some of them can, and these are more short term. And I call these the good, it sounds strange, but I call these the good toxins because you know right away you're being exposed to it, you can do something about it. Consider brevetox. You go to the beach, you know right away you're being exposed to the brevetoxin. Just get off the beach, right? Well, what about these now? Long-term liver damage, or neurodegenerative diseases, or cancer. These things take decades to develop, or at least many years, or usually 10 or 20 years to develop. Okay, you're highly unlikely to discover that because the effects are occurring a long time after the exposure. Pretty much by accident, we think we've discovered one of these, however, and that's a compound called BMAA. It's a very small molecule, actually, and like a lot of these toxins. And I know you can't see numbers. Basically, virtually all blue-green algae produce BMAA. And there's increasing evidence that it can lead to neurodegenerative diseases like Alzheimer's, Parkinson's, and ALS. Now, these are what we call the tangle diseases because a characteristic is you accumulate these, over the course of many years, you accumulate these protein tangles in your brain until they basically kill off your brain cells. Okay, and you can't replace your brain cells. Okay, and they're primarily environmental. In other words, they're only like maybe up to 5% genetic or something. I mean, in a few cases you can inherit this, but for the most part, you don't